Hey YouTube! I'm going to show you something here called about this Rubik's Cube called orbits. A little bit about what they are and how they let you see the beautiful symmetries of the Rubik's Cube. One of the symmetries is the fact that the Rubik's Cube is the only physical model of a quark. And I'll show you what that means. First, let's look at the symmetries of the cube. Notice that if I do this rotation 4 times, I return back here to our red, green, and yellow. Notice if I do this kind of move 2 times, 3 times, I'm back. We have an orbit of length 3. So that's what an orbit is. It's a generator series of moves that you repeat a certain number of times to return the solved cube. 1, 2, 3, 4. That's an orbit of length 4. And I'm going to show you an interesting one, which is goes like this. Did you catch that? It's an algorithm called the Soon or the Allen by Lars Petrus. I forget the name. Did it twice now, and you'll see it's a 3 orbit, n equals 3 orbit. I'm going to do it one more time and show you exactly what's going on here. I've done it once now. You see that my corner pieces are in the right position, but twisted. Clockwise twist has occurred on 3 corners. This is called a hadron. It's 3 quarks, or 3 anti-quarks if you prefer. No difference. I can do that again, and we'll twist them all one more time. Now they've been twisted again, each one of them, same direction. It's 3 quark configuration, stable, called a hadron. Protons and neutrons are hadrons, for example. And back to the solved cube. Okay, here's some orbits of length 3. Now I'm going to show you another orbit of length 3. So, use the generator that you're going to see again in this video, up on the left and then right on the top. And then I'm going to do this rotation. 2 rotation steps. Da-da, 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 da-da. And you see that's another orbit of length 3. Okay, now I'm going to show you a fun one, which is that for a generator. Okay, da-da, da-da. That's twice, 3 times, 4 times. I think I lost track there. 4 times, right? Anyway, let's do another one. 1, like this. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So we have a length 12 sequence, and you saw the quark symmetry emerge with the rotation of these 3 center points in the middle of that pattern. Absolutely beautiful. So let me show you something else. Here's an orbit that starts with this generator as well, and then goes back, the side back and the top back. Da, 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 3 times, da, 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 4 times, da, 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 5 times, 6 times. So we see an orbit of like 6 showing us again the 3 and the 2 symmetry cube. Watch this one now. I'm going to do a similar one, like that. Left up top clockwise. Now I'm going to bring left back, but continue the top in the same direction. Let's do it again. 2 times. 3 times, 4 times, 5 times. Amazing. Isn't it? This really shocked me. 2, 3, 4, 5. And you'll see what's going on here. I'm holding this block. So these are all fixed while I do this pattern. So if you look at the corners, we have 1, 2, 3, 4, 5, 6 corners. But as I'm rocking this side, I keep this corner out of the way of this motion. So this corner is kind of fixed. So there's 5 corners left. And if you follow this corner here, as it goes around when I do this pattern, so now it's here. No, now it's here. 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 Well, one more time. Orange, green, and yellow corner. It's now here. 1, 2. It's now here. It's now here. It's now here. And 5. It makes one cycle. And all the pieces just fit right back where they're supposed to go after that corner makes its one cycle. And you see the beautiful symmetry of 5-fold symmetry on the cube. Alright, one more for you. This is really nice. I'm just going to use that generator that I just showed you earlier, but all by itself this time. So, how many, what's the n on this orb, do you think? How many times do I have to repeat that to get back to a solved cube? Well, I'll show you. 2, 3, 4, 5, 6, 7, 8, 9. Now notice after 9, so you know something? I'm going to go back. Okay, let's try that again. Resolve the cube here for you. Sorry about the cut in the video. You got a, we're looking at this generator. 1, 2, 3, 4, 5, 6, 7 times is what I meant to show you. 7 times we have these crosses are good across the sides. And we've just moved the corners around after 7 moves. And you'll see a little 7-fold symmetry there. 1, 2, 3, 4, 5, 6, 7. See, there we are again, corners shuffled. Let's do it a third time. 1, 2, 3, 4, 5, 6, 7. And now you see we have something kind of interesting called a heptaquark. And we've got a couple meson pairs here. 3 pairs of mesons. That's a hexaquark. And it took us 21 moves to get here. So from what we know about quark symmetry, we'll see that another 21. We rotate these again. We'll just do the same thing that we've just done here. You can see this rotation we've done to the cube with 21 generator moves. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And there we have the the same heptaquark of before. It's not an antiquark. It's just the second rotation of 3. It's a family of 3. So 21 more moves. Bring us back to the solved cube. So we have an orbit of length 63 there. And I'm gonna just give you another example. This orbit here, this time I move the right side up and then do the top move instead of this other I was doing. Let's try to do this. What do you think that would be? Well, I'm not going to do it for you, but it turns out to be 105. Which is 7 times 5 times 3. It's absolutely beautiful, is it not? And here's another couple questions for you. Since you watched so far, can you help me? Here's a generator. Right. Done it once, done it twice, done it 3 times. Well, I'm not going to do it for you because I don't know the answer. I'd like someone to tell me what it is. That's all for now. Thanks, guys.